So we are asked for the following series. Does it converge or does it diverge? We're not asked to find the sum of this series, just does it converge or diverge? Pretty simple idea here. Sorry, I dropped my marker. Let me grab that. Silly little thing. Thought he could get away. Not today. But basically, to find if this thing is convergent or divergent, we need to do a simple test. Now, we can do the divergence test, meaning that if we take the limit of our sequence of terms and it is turning out to be something that's not zero as we approach infinity, well, then we know that that is going to be divergent. Anything else is indeterminate, which would be zero. If the limit is equal to zero, then we know that our series is going to be indeterminate, and therefore we need to do what's called the integral test. So, meaning that you clicked on this video, you probably know that this is going to be an integral test, but it's always good to start with the simple divergence test because it's pretty nice. So what is the limit as n approaches infinity for n squared over n to the third plus 1? Well, we know that evaluating this is going to give us infinity over infinity. N squared is infinity, n to the third plus 1 is infinity. That's indeterminate, so what we need to do is we need to use L'Hopital's. And we're actually going to have to use it twice because of this being a square. We need to get it to a constant. We can't have infinity over anything. So we're actually going to turn out it's going to be 0, but I'll just show that real quick. We're going to use 1 L'Hopital's to n over 3n squared plus 1. If we took the limit of this would be indeterminate, so we do L'Hopital's one more time to give us 2 over 6n plus 1. Evaluate the limit now. It's going to be 2 over infinity, which is just going to simplify to 0. If I have 2 cookies and I split it up infinite amount of times, no one gets any cookies. They don't even get an atom of a cookie. They don't get a quark of a cookie. They get 0 cookie. Okay, because think about it like this. For y, 2 over infinity, 0, just for those who might not know, 1 over 1 is 1, 1 over 2 gets smaller. If we look at this as a function of 1 over n, if I plug in 1 over 10,000, this number is even smaller, 1 over a mole. Okay, 1 over infinity. Infinity is an indefinitely large number, therefore it is 0. Okay, hopefully that idea makes sense. So we know that the divergence test is indeterminate because it gave us an answer of 0. And therefore, we have to use the integral test. So let's go ahead and do that. The integral test says, take this and put it as a function. So instead of a series, pretend it's a function. So this is going to be, I'll put it in terms of x just so we can differentiate the series from the function. And then take the integral of this from wherever your index starts. So we're starting at 1 and we're going to infinity. So this is 1 to infinity. This means that this is an improper integral as such. Let me just remove that. So we're taking this improper integral. That means we have to write this as a limit as b approaches infinity. Right? Because we can't plug in infinity for our integral, so we just rewrite it simply as this. Hopefully you see that this is a little bit of simple u sub. I'll write it in red for you, where u is going to be equal to x third plus 1, where du is equal to x squared, or sorry, 3x squared. But notice here, our du is only 1x squared, not 3x squared. So du, we're going to have to divide by 3 to get du over 3 is equal to x squared. Okay, so let's rewrite this integral as a function, or as a, in terms of u, my apologies. And I'm going to bring out the 1/3 all the way in the front. Okay, so this is 1 over u. This means that this is a natural log when evaluated. Just looking at it, because 1 over u, the integral of that is natural log absolute value. So this is going to be the limit as b approaches infinity 4, 1 over u, well, that's going to be ln, and this is just 1/3 of that. 1/3 ln of x to the third plus 1, evaluated from b to 1. Okay, now let's evaluate our limit. Ln is going to be infinity. So our b term, we plug in b here. We're going to evaluate the limit. We're going to get the natural log of infinity, which is infinity times a third. That's going to be infinity. So what this turns out to be is infinity minus whatever this is evaluated at 1, which we don't really care about because we have an infinity term. And anytime we add, subtract, multiply, divide infinity by everything, it remains infinity. So therefore, the integral, as we go from 1 to infinity, the area under that curve, if this was a function, is infinity. So if it's infinity, what does that say about our series? Well, think about the series as a sequence. This is a sequence. N equals 1, n equals 2, n equals 3, n equals 4. X equals 1, x equals 2, x equals 3. If the area under this curve is infinite, what does that say about the sum of all the values for the series? Well, that says, and basically you can look at this as an integral. If it goes to infinity and our function is divergent, what does it say about our series? Well, it says it's also divergent. It doesn't converge to a single value. Now, if the integral test would have given us a finite number, we would not have known if that is the sum or not. It's impossible to tell if the integral's value that we get is a sum or not. It's just impossible. We were only asked, is it convergent or divergent? And we found through the integral test that it is actually divergent. I hope that you guys enjoyed this video. If you did, please drop a like, comment, and subscribe. I hope that you have a wonderful day.